This is Bill Langdon. I'd like to talk about my poster at Gecko. So the idea is we're going to use genetic improvement not to directly improve software, but to improve its use of the cache. So the question is why we want to do this. And the first answer is, well, programming is hard. And parallel programming is very hard. Efficient parallel programming, in other words, making the best use of the cache, is very difficult. In practice, often impossible. So, but the downside of that is the future is increasingly to do with hybrid computing. So machines with digital signal processors, FPGAs, multi-core GPUs. For instance, in the last 4 years, the available count on core count on GPUs has increased by a factor of 4. If this doubling every 2 years continues, within 5 years, we could expect more than 100,000 CPUs on a laptop. Today, that's a sort of compute that's only available in top-end supercomputers. So the upshot is computing is increasingly cheap. What is expensive is actually data, particularly moving the data. And the point is to actually perform computation, the data needs to be at the CPU, and the cache is how we actually get data and CPU together. The problem is the caches are often totally black box, secret algorithms within them, and frequently changing between different machines. So in other words, the cache is not only difficult to program, but in practice it has to be done automatically. You can't reprogram your software each time the cache changes. So what we're going to show is genetic improvement is a credible way of at least starting to tackle the problem of automating best use of the cache. Here we're going to use the Magpie system. And the upshots are by adding the L1 data cache statistics, in particular how many times we get misses during the operation of a program, we can optimize software. And in the poster we look at 4 different programs, 3 of C, 1 of C++, 2 industrial, and the other 2 are open source, 1 from VLC, the other is benchmark. And what we show is where the data is rich in essentially in image processing, the 2 image processing examples, we can find better software, makes better use of the L1 cache entirely automatically. So the point at the bottom, that code is not fragile. Yeah, if you mutate code, it can go wrong. But if you're prepared to try multiple times, prepared to have a population of mutants, then you too can evolve great things. At that point, I should really stop. So thank you very much.